Section 5.2 Interactive Assignment Objective 3. The data on the right represent the number of live multiple delivery births, 3 or more babies, in a particular year for women 15 to 54 years old. We're going to use the data to complete parts A through D below. So I'm going to go ahead and open this up. So I've copied this table. Okay. Now the first part, it says to determine the probability that a randomly selected multiple birth for women 15 to 54 years old involved a mother 30 to 39 years old. Before we can answer the question, we must create a probability distribution. So just like we've done with a frequency and relative frequency distribution, we're going to go ahead and do that. So the first thing is that we need to find the total of the number of multiple births. So when we add those together, 94 plus 511 plus 1630 plus 2825, 1850, 371, 117. When we add those together, we get the following total, which is 7,398. And then we got to find the probability of each. So remember that we need to find the probability by taking the frequency and then dividing it by the total to give us rounding this. So we got to round each one of these to 3 decimal places. So this is 0.013. The next one is 0.069, 0.220, 0.382, 0.250, 0.050, 0.016, and then when we add those all together, we should get 1. So therefore, we have to find the probability of each and making sure that we find the total. Now we can go ahead and take a look at this question again. We want to find the probability that randomly selected multiple birth for women 15 to 54 years old involved a mother that is 30 to 39 years old. So what we want to do now is if we take a look between 30 to 39 years old, now we see that we have a class of age that is 30 to 34, and then we have another one from 35 to 39, which would then describe 30 to 39 years old. So when we're searching for this probability, that means we need to find the probability from 30 to 34, and then plus the probability of 35 to 39. Well, we've already done that by finding the probability. We know that the probability from 30 to 34 was 0.382. And we know that the probability from 35 to 39 is 0.250. So now when we add those together, then we're going to get 0.32. Okay, so let's go back, and then we're going to put in our result, and scroll up here. So the probability between 30 to 39 is 0.632. Okay, next, it says determine the probability that a randomly selected multiple birth for women 15 to 54 years old involved a mother who was not 30 to 39 years old. Well, in this case, we got to use the complement. Okay, so to find that is not, we're going to take 1 and then subtract the probability that we found in the previous step, meaning 30 to 39. So we're taking 1 and then we're subtracting 0.632, and when we subtract that, we get the complement, which is 0.368. And so therefore, the complement is going to be 0.368. Now, the next question says to determine the probability that a randomly selected multiple birth for women 15 to 54 years old involved a mother who was less than 35 years old. Okay, so again, we want to use the idea of the complement. Okay, so if we want to find, again, a mother who is less than 45 years old, okay, what we're looking for here is the probability that is less than 45. That's going to equal 1 minus the probability that is greater than or equal to 45. So, what is greater than or equal to 45? Well, if we come down here, okay, what is greater than or equal to 45? Well, if we take a look at our age, the number that's greater than or equal to 45 is 45 to 54, and we can see that that probability is 0.16. So we're going to take 1 and subtract 0.16, and when we do that, we get the result of 0.984. That means if we add all these up together, and let's go ahead and do that. That means if we add all these up together on a calculator, okay, if we add these up here, okay, and let's go ahead and do that. So let's add these up. So we're going to add up 0.013 plus, 0.013 plus 0.069 plus 0.220 plus 0.382 plus 0.250 plus 0.050, and that should give us 0.984. So again, that means that we added this, which is all less than 45, but by doing a complement, that's what we get quicker. So another way of looking at this is just remember the difference between the symbols. Less than is the less than symbol of 45. The opposite of less than is greater than or equal to. Okay, now in the last part it says we want to determine, and let's go ahead and put that answer to make sure that answer is correct for part C. The answer for part C is 0.984. Okay, now let's take a look at part D. Part D, it says, determine the probability that a randomly selected multiple birth for women 15 to 54 years old involved a mother who was at least 40 years old. We want to interpret this result, and then, is it unusual? So we have to find the probability that a randomly selected multiple birth for women 15 to 54 years old involved a mother who was at least 40 years old. Okay, now, at least means anything that is greater than 40 or equal to 40. Okay, so we want to make sure that we know that at least means greater than or equal to versus at most, which is less than or equal to. So you want to know the differences between those two. So in this case here, we want to figure out at least. So to find at least, we need to find all the numbers, okay, that are greater than or equal to 40. Well, all the probabilities that are greater than 40, we have 0.050 and 0.016. So 0.050 plus 0.016 is going to give us the following, 0.066. Okay, so therefore there is our answer. Now we need to interpret this result. Well, how do we interpret this result? Well, we need to write this as a fraction. So the last 6 ends in 1,000 place. So that means that this is 66 over 1,000. That means out of 1,000, we would expect that 66, okay, of them would involve a mother who was at least 40 years old. So we would say that if 1,000 multiple births for women 15 to 54 years old were randomly selected, we would expect about 66 of them to involve a mother who was at least 40 years old. Okay, so then that would be our next answer. We would choose that option. Okay. Now the last question is asking us, is a multiple birth involving a mother who's at least 40 years old unusual? Okay, well, we found the result to be 0.066, and this is the question that we want to ask. Now, to determine whether a multiple birth involving a mother who was at least 40 years old is unusual, we want to compare the probability to 0.05 or 5%. Now, if the probability is less than 0.05, it is unusual. Otherwise, it is not unusual. Okay, so we're going to say the probability at least 40 versus 0.05. Well, we know that from our result, we see that 0.066 is actually greater than 0.05. And since it's greater than, we would say that it's not unusual. So we would say no, because the probability of a multiple birth involving a mother who was at least 40 years old is greater than 0.05. And therefore, looking at our result, there is our answer.